Section 12.4, Introduction to Polynomials. Okay, we're going to classify the polynomials by the degree and number of terms. Evaluate polynomial functions written using function notation. Let's look at some definitions. Okay, a monomial in x is the term of the form k x to the power of n. Okay, where k is a real number, okay, n is a whole number. N is called the degree of the polynomial, and k is called the coefficient. Okay, so basically it's looking at something that looks like this, and I'll go ahead and we'll get plenty of examples, but it'd be like saying something like 2x squared. Okay, well, there's the whole number. Okay, x is just going to be a variable, and then 2 here is going to be called your coefficient. Okay, so these are going to be some things you're going to want to remember. So here is the degree, okay, and here's the coefficient, and then okay, and there is the variable. Okay, let's continue on. Okay, a polynomial is a monomial, or the indicated sum and or difference of the monomials. The degree of the polynomial is the largest of the degrees of its terms after like terms have been combined. Okay, once we simplify it, okay, what is the degree after that? And the coefficient of the term of the largest degree is called the leading coefficient. Okay, let's kind of continue on with our definition here. Okay, term, monomial, polynomial with one term, such as negative 2x to the third, where the degree would be a third degree polynomial with a leading coefficient of negative 2. Okay, here is 4a to the fifth. The leading polynomial is, the leading coefficient is 4, and our degree is 5. Okay, binomial, polynomial with two terms. Okay, notice we've got 3x plus 5 and a squared plus 3a. This is going to be a second degree polynomial with a leading coefficient of 1. Okay, because we remember, whenever there's nothing here, there can be assumed that there's a 1 there. Okay, trinomial, a polynomial with three terms. Okay, a squared plus 6x minus 7. Okay, it's a second degree polynomial, and the leading coefficient is 1. Here's a third degree polynomial with a leading coefficient of 1 as well. And then polynomials with 4 or more terms are simply referred to as polynomials. Let's do a couple of examples real fast. So simplify each polynomial by combining like terms, write the polynomials in descending order, and state the degree and type of each polynomial. Okay, let's do this first one here. Notice we have 5x to the third plus 7x thirds. Well, 5 plus 7 is going to give us a 12. And notice just combine like terms because we've got 12x to the third. This is just going to be a monomial with and it's going to be a third degree. Okay, well, let's look at the next one here. I've got 6x to the third plus 4x to the third. Well, that's going to combine and give us 10x to the third. And then notice this minus 2x. You cannot combine that with the others, but we still have a third degree polynomial. Okay, and that's how this is all going to go. So let's do one more little example here, and it's going to be whenever they give us they're going to give us a value for x. So let's look at one like this. Given the polynomial p of x, it equals 4x squared plus 5x minus 15, where p of 3. Okay, maybe basically what this is saying, take that 3 and anywhere that you see an x, replace that with a 3. So p of 3 is going to equal, well, 4 times 3 squared plus 5 times 3 minus 15. Okay, we'll continue on. We've got 4. Well, 3 squared is going to be 9 plus 5 times 3 is going to be 15. And then I'm going to have this minus 15. Let's come over here and notice that I can reduce out those 15s because they're just going to cancel. And then we got 4 times 9, which is just going to give us 36. So our final answer for this one, it will be 36. And that's how basically things are going to work on in your homework. So let's continue on.